Quantum computing. There are a lot of articles and videos on the internet that explain quantum computers. But to be honest with you, most of them are pretty advanced and confusing. So, I am going to try to clarify the definitions in an easy-to-understand way. We all know that normal computers use bits of 0 and 1s for the purpose of data manipulation and computation. For example, if I have 2 bits in a row, I can represent 4 numbers. If I have 4 bits in a row, I can represent 16 numbers. Quantum bits, which we also call qubit, are also 0 or 1, but they can also be 0 and 1 at the same time. Does it sound odd and confusing? Well, it is not. It is really pretty easy to understand. Let us assume, for example, that the bit is a coin. It can be either heads or tails. Same as 0 or 1. Now, the question is, will it be only either heads or tail? Incorrect, it may be heads and tails at the same time. Wait a second, take your seat back, and let me explain it to you. If I have been flipping this coin, you can see it as rotating in the air. What is up right now? Are they heads or tails? Now, in a curious way, they are heads and tails at the same time. It does not make any real sense until it collapses in my hand. Then I see the coin, and finally, I can see what it is, either heads or tails. And that is the principle behind the quantum bit. It can be 0 and 1 at the same time. Okay, fine. So, what does this have to do with the computers? Okay, this is when the fun begins. Let us get back to the 4 bits we have talked about before. Let us just assume that I am trying to crack a password. The password I am trying to break is one of those numbers which are held by the 4 bits. But I don't know which one is the right password. So I've programmed the computer to try it all, either sequentially or randomly. It is a normal computer. I take a number, which I put in my computer, and if it is wrong, it gives me X. But if it's right, if the password is right, it gives me Y. So, after many trials, I have got the right number. So, a regular computer will attempt, more or less, each and every one of these numbers, individually, until the correct answer is found. Now, what if we are using a quantum computer? So instead of putting in these 4 regular bits, like we do in a normal computer, we are going to put in 4 quantum bits. Back to the basics again. Remember that each bit is either 0 or 1. So, for 2 bits, they may be either 0 0, or 0 1, or 1 0, or 1 1. In the same way, each qubit is either 0 or 1, and even 0 and 1 at the same time. So, for 2 qubits, it can be either 0 0, or 0 1, or 1 0, or 1 1. Now, hang on to that idea for a second. Since the qubit can both be 0 and 1 at the same time, this means that these 2 qubits can hold all the number all at the same time. So, when I put the qubits in my computer to find the correct password, it turns out that what comes out at the other end is that the computer gives both the correct and the wrong answers at the same time. Since the qubits hold both the correct and the wrong passwords at the same time. But I still want to know the correct password. Okay, there is a method called the Grover algorithm. Sure, this is really a true thing, where you can sweep out all the wrong answers, and what you are left with is the correct one. So, this is the beauty of quantum computing. Instead of trying each and every value like a normal computer would do, a quantum computer tries them all at the same time. In real world, high security encryption is used in secure communication, storing data securely, and keeping the password and codes safe. It will take millions of years for a normal computer to try to break those codes. That is how safe they are. So it is impossible to crack them with normal computers. But with a quantum computer, you can test all the codes at the same time. At the end, by using the Grover algorithm, you will be able to sweep out all the wrong answers. And finally, what you are left with is the correct one. So, instead of using a normal computer for millions of years, you can do it in seconds with a quantum computer. Now, what other things would you do with a quantum computer? Well, let us take something that we're familiar with. What about the distance between the 2 points on Google Maps? What does regular maps do is they look at all the different possible paths between 2 points, try them one at a time, to figure out which one is the fastest, which is the shortest distance, which is the optimal one. This takes a long time, and takes a lot of computation. Now, with a quantum computer, you can explore any possible way between 2 points, all at the same time, and choose the right one instantly. This is huge, because the rise of self-driving cars is coming. Imagine having a master system, which is a master quantum computer, super brain, for all the brains, managing the entire system. This system will continuously be optimizing every vehicle that is out there on the road. The system will be figuring out the best alternative routes while self-driving in real time to avoid hazards and accidents. The system will be figuring out when the lights should turn green or red. And instantly, the system will change lanes, take exits, to give you the best possible commute in every ride. Because it is literally tried everything, with every possibility, and has found the one solution that is the best. That is a quantum computer, while regular computers could never do that. Okay, I hope you have been inspired. If you did not already know, you may now understand how quantum computers work, and what the potentials are. If you find it helpful, feel free to like it, share it, and thank you very much for your time.